All right, so on Tuesday we covered structural testing, and just want to go over that real quick. We contrasted structural testing with functional testing. In that functional testing that we covered the week prior focused on the specified behavior. Right, we looked at the specification. We saw that how the application was advertised to behave, right? That with these inputs, these were the expected outputs, and we had to verify, right, that behavior, right? We had to create unit tests that actually exercise those specifications and see if indeed it was behaving as advertised, without being concerned with anything that was actually internally implemented in the source code. So we didn't care anything about was inside the black box, right? We treated the application as a black box. We did that by identifying some boundary edge cases, right? That were values of interest, right? Whether it was and then we created unit tests that exercise those boundaries, because we tend to, as developers, we tend to make mistakes interpreting those boundaries, right? Whether we're going to loop one too many times, one too few times. Do we go above or below? And so we want to make sure that at least those edge cases are taken into account. But there were some edge case, some algorithms that didn't seem to have an edge case, right? They seem to consider a huge amounts of a number of possibilities that we needed to test. So instead, we looked at some other examples on if we knew the algorithm. What could the algorithm tell us on where we should focus our testing? And we looked at this trivial example on calculating the roots, and we see that the values inside, depending on what those values are, looks like the application takes one particular branch or another. Right. So here we can look at the algorithm to give us some idea on what those edge cases might be. Right. That maybe the value of A does have some insights that we need to take care into account, that A might be 0, right? We might be divided by 0. So we're going to make sure that our unit tests, make sure that force our application to flow in those areas where a particular value might be of interest. Right. So we want to select some values that force the application to exercise every single nook and cranny of our application, but once it was in that particular branch, to exercise certain values that were of interest, because of the algorithm might have some flaws or some errors in there that we want to make sure that they are vetted. So we came to a conclusion that yes, it's important to look at the algorithm so that we can come up with values that force it to go one way or another. So in this this week we're gonna take a look at the coverage and see what is the ratio of how many lines of code we have implemented so far, and if our inputs, right, from functional tests, whether they force us to go through every single nook and cranny in our algorithms. Right, it might be that the edge cases that we thought of in our unit tests last week actually are not exercising every single branch, every single if statement, every single loop that we have in there, right? We don't know that, right? Because our edge cases that we chose were specifically from the specification, right? We don't really know if they exercise it. So that's what we're going to focus on this week, right? Exercising certain values of the input and see what the coverage tells us, right? We talked about using being able to calculate the code coverage. And various ways of measuring whether you were counting how many statements, whether you were counting how many branches, and we saw how rigorous each criteria was. Even further, depending on how many times you want to count it, loops and while loops or paths and whatnot. We also talked about a couple of tools that allowed us to do this in GCC. We talked about some branching criteria. Anyway, so we'd like to be able to apply these measurements to give us an idea on what the inputs might be that we should consider. If we see that our branch coverage is less than 100%, right? It must be that our unit test there's something missing in our unit test, right? That we wouldn't have caught it if we didn't exercise and actually count it if we went through every single loop or statement. So we need to identify what exact value of that input fields would cause the code to pass through some part of the code that is not being exercised. Okay. Anyway, we also talked about some tools that I asked you to install last week. If you were using IntelliJ, I asked you to please go over this video, which covered some of the tooling that you need to be able to do code coverage in IntelliJ. If instead you're using Eclipse, I had asked you to take a look at this plugin, the ECL Emma plugin, right? That paints your code red or green or whatnot to highlight which parts of the codes are being exercised and which are not being exercised, right? And try to see what calculation is it that would give you some idea on how good a unit test you might have. Okay?